All right, so let's continue. So we're on number 5. Use the logarithm table to calculate the following logarithms. Well, there's a couple things that we're doing here. What we're doing is we're remembering the rule that says that if I have, let's give ourselves something to write with about green. If I have log of, say, A plus log of B, I can change that to log of A times B. And if I have log of, say, A minus log of B, I can change that to log of A divided by B. And then I also have, if I have log of, say, A to the second power, I can change that to 2 times log of A. So we're using these rules here for logs. So let's see what we got first. Well, I got log of 70. Well, if I'm looking here, there is no 70. But what there is, give myself some blue, I can have log of 7 times 10 because that's what 70 is. So now this goes back to here. Log of AB equals log of A plus log of B. So then that's what I write next. I say log of 7 plus log of 10. So log of 7 is over here, is 0.8451. Log of 10, oh wait, log of 10 isn't over there. But what's the base for log when there's no base there? It's 10. So when I have log base 10 of 10, what does that equal? Well, I'll give you a hint. Remember, log base 10 of 10 equals what? Well, what does this mean in exponential form? The base is 10, and what is that? Well, that's the equals. So 10 to what power equals 10? Remember that log is just kind of what the power function. So that's going to be 1. So when my base is, or my base and the number I'm taking of the log is the same, then they just cancel each other out and I get 1. So that's going to be 1. And now I can add that. If I add a point 0 on the end, I line those up. 1.0, add those together. My answer is 1.8451. So, now I've got log base of 1500. Well, I'm going to do the same thing that we did. Log of, say, 3 times 5 times, what is that, 100? Now, why did I multiply 3 values out? Well, I multiplied 3 values out because I knew how I could get 15. That's 3 times 5. But then I still got to deal with these two zeros, which means I'm multiplying by 100. Well, if I break this down now to log 3 plus log 5 plus log of 100, well, 100 is 10 to the second power. So now what do I got? Well, log base 10, because remember, no log there or no base, it means it's base 10. Log base 10 of 10 to the second power is just 2. And then I've got log base 5, or base, sorry, log of 5, that is 0.6990. And then I've got log of 3, that's 0.4771. So then I line all three of those up. 0.4771, 0.6990, and then 2.0. There's several ways. If my base and the number that I'm taking the log of are the same, the answer is 1. Well, what if they're 2? Well, remember what I told you right here. that if I have an exponent, I can take that exponent and put it in front. So log of a to the second power is 2 times log of a, because all I did was take this exponent and put it to the front or multiply it. So that's what I could do here. I'll move that 2 to the front. Log of 10 is 1. 2 times 1 is 2. Another way you can look at it is I've got log base 10. You know what I'm going to say? Forget it. That's fine. I can take the exponent, move it up front, and then the log is going to be 1. So it's 2 times 1. So anyway, I add those three things together. I get 1, 16, 17, 11. So the answer to this one is 3.1761. Now I got log base 0.08. So I know that log of 8 times 10 to the what? -2 power? Because if I've got 8 and I multiply by -2, I move the decimal 2 places. So I've got log of 8 times 10 to the second power. Well, because it's being multiplied, I can separate and say that's log of 8 plus log of 10 to the -2 power. Well, log 8 is right here. So that's 0.9031. Excuse me. And then here, I've got log of 10 to the second power. So that's going to be a -2. So now I've got to subtract 2. So in this case, I'm going to say 2.0000 and 0.9031. I'm going to subtract. So I need to borrow it right there. That's going to be 10, and then that goes to 9. And so with that, I make that 10, and I'll make that go to 9. And then this is 10. So 10 minus 1 is 9. 9 minus 6 is 3. 0 minus 0. 9 minus 9 is 0. And then I've got 1. So that's 1.0069. Now wait. See, the thing is, I subtracted. I made this a positive and that a negative. Well, my 2 is what's negative. If my number that I'm subtracting is negative, or my bigger number is negative, excuse me, or is minus, then my answer is minus. So this is the answer. And then finally, I got log of 24. So log of 24 is either 6 times 4 or 8 times 3. I'm going to go 6 times. Well, I'm going to go 8 times 3. Well, no, I just did 8. So let's do 6 times 4. So that's 6 times 4. So that's log of 6 plus log of 4. And so now I just take the log of this and the log of this and add them. So the log of 4 or the log of 6 is 0.7782. And the log of 4 is 0.6021. And then I just add those two numbers together. Make sure the decimal points line up. 3831. So that answer is 1.3803. All right, so that's all of those. Let's look at what's next. Yes. What's the problem? Like I said, you can just watch it later. All right. Describe the transformations of each of the following functions using the parent function. So the parent function, that's what it starts off. So whatever I do to this and whatever I do to this, those are going to change where my graph lies. Now the stuff inside the parentheses, it does the opposite of what you see. So if it's -9, it's going to go 9 units to the right. Because see, if I'm looking at a coordinate plane, the negatives on this side, the positives on this side. So you would think negative goes left and positive goes right. But for some reason, the laws don't work that way. It works just the opposite. So inside the parentheses, that x minus 9 tells me that I'm going to go 9 units to the right. Now, the number on the outside of the parentheses, that's adjusting my y-axis. So that's either going up or down. And there's no crazy restrictions on that. So if it's positive, it's going up. If it's negative, it's going down. So then that's 6 units um, up. And so now I got this problem. So I've got x plus 12. So x plus 12 goes 12 units to the left. And it goes 5 units. Oh, sorry, I just had a brain fart. So 5 units down. So that's 12 units to the left, because usually it will go to the right, but seeing as we do the opposite of what that sign says, it's going to 12 units to the left, 5 units down. And that's all that problem involves. So now the fun stuff. Okay, so now we got vertical asymptote, domain, and x-intercept. So the domain happens when you take what's in parentheses and set it equal, well, excuse me, set it to greater than a 0. And you solve this, and that gives you your domain. So I'm going to say 5x minus 30 is greater than 0. I'm going to add 30 to both sides. 5x is greater than 30. And then I just solve the inequality. I divide by 5 on both sides, and I get x is greater than 6. And that's my domain, that I can pick any number that's bigger than 6. Another way you can write that is 6 to infinity. So that's the domain. And then we got the vertical asymptote. The vertical asymptote is you take the same part that's in parentheses, and now you set it equal to 0. So I've got 5x minus 30 equals 0. So I add 30 to both sides. And that's going to give me 5x equals 30. Then I'm going to divide by 5 on both sides, and I get x equals positive 6. So this is my vertical asymptote. And then finally, I'm going to do my x-intercept. And I do my x-intercept by taking my original equation and substituting 0 for y. And now I want to solve this. Well, my base for my log is 2. So if I exponentiate, I get rid of the log. And exponentiate just means all of my stuff, I take it to the base of this base, so 2, and then that stuff is exponents. So I can figure out what 2 to the 0 is. It's 1. 2 to the log base 2 of whatever. The log 2 and the 2 are going to cancel each other out, and I'm just going to have 5x minus 30. And now I solve this. I add 30 to both sides, and I get 31 equals 5x. And then I divide by 5. And so that's 31 over 5 equals x. And that's how that goes. This one works similarly. So I got the domain. Domain says I take 3x plus 10 is greater than 0. Subtract 10 from both sides. 3x is greater than negative 10. Okay, so 3x is greater than negative 10. So I'm going to solve that inequality by dividing by 3 on both sides, and I get x is greater than negative 10 over 3. You don't need to change that to an improper fraction. You can leave it the way it is. So next, we've got the vertical asymptote. That is, wait a minute, oops, I messed that up. No, that's not right. Equals 0. So 3x plus 10 equals 0, right? So what do I need to do? Subtract 10 from both sides. 3x equals negative 10. Then I divide by 3 on both sides and get x equals negative 10 over 3. And then finally, I need to do the x-intercept. So the x-intercept is writing this out. So I've got y equals log of 3x plus 10. So with no log there, oh, whoops, I'm sorry, minus 2. So with no log there, first thing I'm going to do is I'm going to change my y to a 0. Second thing, I'm going to add 2 to both sides, and then I'm going to run out of room. So that's 2 equals log 3x plus 10. And then from there, I need to exponentiate. Let me see, can I make some room somewhere? All right, so let's go back up here. 2 equals log of 3x plus 10. And so the next thing I'm going to do is I look at my base for my log is 10. So I'm going to exponentiate and put 10 on both of these. So that's going to be 10 to the second power equals 10 to the log 3x plus 10. So when I do that, this I get 100 over here equals the 10 and the log base 10 cancel each other out. So that's 3x plus 10. So then I subtract 10 from both sides. That's 90 equals 3x. I divide by 3. All right, so let's see what's next. Couldn't hear you. Oh, I'm sorry, I didn't do it. X equals 30. 90 divided by 3. Man, I'm about to pass out doing this. I'm all stopping. Okay, so anyway, the next one is solve the following exponential equations. So I've got 3 different situations here. The first situation, my bases are the same. If my bases are the same, it would stand to reason that my exponents are the same. So I can just set them equal to each other. And then I solve it. Well, I'm going to get 3x to the other side. and that's going to be 2x equals 4, and then I divide by 2, and x equals 2. So now I'm going to do this one. Well, my bases aren't the same. So you could kind of work around it, or you can change this and make that 3, 6x plus 9 equals, and 27 is 3 to the third power. Now I have the same bases, so now I can just set stuff equal to each other. Because whatever's in this parenthesis should equal this if they're both equal. So I got this. I'm going to subtract 9 from both sides and get 6x equals negative 6. And then finally, okay. So I got this problem. First thing I'm going to do is subtract 8 from both sides. So that's 6 to the 4x minus 5 power equals, what, 11? Well, I need to get to the x. So I know I can get to the x by taking the log base 6 of both sides. So now the log base 6 and then the 6 exponent, they cancel each other out. So I'm going to have 4x minus 5 on the left side. And on the right side, I'm just going to have the log base 6 of 11. Now that's an actual number, but since you're not getting calculators, you don't have to worry about finding what the actual number is. All you need to do is deal with this. So the next thing I'm going to do is I'm going to add 5 to both sides. So I'm going to get 4x on the left. I'm going to get log base 6 of 11 plus 5. And then I'm going to divide by 4 on both sides and get x equals log 60 plus over 4. Oops, that's 11. Let me write that again because that looks confusing. Base 11 plus 5. So this is my answer. X equals log base 6 of 11 plus 5 divided by 4. And we're going to pause on that.